Hi, welcome to Mat181 Pre-Calculus Trig. What we're going to talk about is probably the best part of trigonometry today, which is using your calculator 2.3 and then using your calculator to solve problems. So I'm going to use the TI 30X 2S because this is the calculator I'm most familiar. You can use TI 84s, or you can use Casio or whatever, but you're going to have to check your booklet to kind of see the directions for those things. I'm going to show you the directions on this one, which should probably be pretty universal, but just to make sure. Number one, the most important thing you can do is always set your calculator to degrees. To do that on this one, it's pretty easy. Next to the second button, you're going to see a DRG key. Hit that DRG key and make sure that degrees is underlined. Later on, we're going to be working in radians, not so much gradients, but we'll be working in radians. So then you have to reset your calculator. So if your calculator is not set to degrees, make sure it's set. Now, if you're using a Casio, sometimes you have to go into mode and it can get kind of tricky. But you want to make sure that your calculator is set to degrees. Because I don't know how many students turn in these problems and all of a sudden they're all in radians, and I have to count them all wrong because I'm looking at my answer key and it doesn't match at all. Because if you do the problem in radians and you do it in degrees, you're going to get totally different decimal equivalents. Okay, so now if I get calculators hit in degrees, I can just hit that or hit my enter key, make sure it's underlined, and bing, I'm ready to go. Okay, so I'm going to look at section 2.3. Let me find that. It's on page 61. Let me write that down right here, 61. And we're going to start off by looking at this problem right here. Sine 49 degrees, 12 minutes. Well, you know what we had to do on this one is we had to take the 49 degrees, and then we had to add to that. We had to take the 12 minutes, and we had to change that to 12 over 60, and then combine these together and all that junk. Okay, there's an easier way. If you look at this calculator, and you go down the third column and go down, you're going to see a 0 with a line with the two lines. This is degrees, minutes, seconds. So all you have to do is hit sine 49, and now we're going to hit, because we are in degrees, but we still want to hit the degree key. We want to go over here and see how degree is underlined. See how that's underlined? So we want to hit equals, and now it's 49 degrees. In 12 minutes, we want to go 12, same key, slide it over. How do we slide over? We use these keys so that the one line is underlined and hit equals, and you can see there's other functions there, like for radians and gradients. So we're going to make sure that's underlined. And then we're going to close our parentheses. We hit the equal key, close parentheses, and then hit equal. And it's just that easy. Normally, we carry these out 4 decimal places. The book carries it. Got a little carried away. But we'll write the whole number down here. 699. Oops, 0 was sloppy. 0, 5, 6. Speaking about sloppy, I've seen your work. This would be actually written pretty neatly. But normally we would round this off. Let's see if we were going to round this off. We'd probably call this 7. And we would round this off to, we'd keep this a 5, round this off to a 7, 0, round it off. Even if you went to 0.7569, it's not going to be terrible. It'll throw you off a little bit, but not terrible. Okay, so that's how you change degrees, minutes, seconds. Let's go back and look at this and see degrees is now underlined again. So it'll go back to the initial setting. Let's clear that out. Okay, next thing I want to find is the secant of 97.977 degrees. So I have a 97-degree angle, and I want to know what the equivalent is on my calculator. But I want the secant function. If you notice, you only have sine, cosine, tangent. I'm going to find the secant. Well, I remember that the secant is 1 over the cosine. So if I put 1 over the cosine of 97.977, I should be able to find the secant. So I'm going to hit 1 divide cosine parentheses 97.977 parentheses equals. And that will give me the equivalent of the secant. So remember, the secant and the cosine are reciprocal functions. And that's why you have to kind of remember some of that stuff. I'm going to write the whole thing down because the book did. You know, if it doesn't tell you to write out that many, then maybe just 4 places. And let's round this up. To round up, look at the last place. Look at the number after it. If it's a big number, we're going to round it up. Okay, how about 1 over the cotangent? 1 over the cotangent of 51.484283 degrees. Well, again, what's the relationship between the cotangent and what? That's right, tangent. They're reciprocal. So all you got to do is look up the tangent of 51 degrees, 0.484283, I should say, degrees. All right, so let's put it in, see what happens. What's the worst that could happen? You don't get it right. Tangent, where was my problem? 51.4283 parentheses equals. Don't have to hit the degree sign, you know, because it's already set to degrees. So what did I get? I got 1.2539. I'm going to just stop right there. Okay. Let's try. Oh, what if we had an angle? Here's a negative angle, and we could even use this if the angle was bigger than 360. Well, I'm going to hit sine. I don't need a reciprocal function. I'm going to hit my negative key down here. Don't hit the minus key. 246 parentheses equals. Pretty easy, huh? 0.9135. 0.9135. I'm not going to round it up because the next number is a 4, and that's a pretty small number. So I'm not going to round it up. It's got to be 5 or bigger to round up. Okay, pretty cool. All right, so this is a little fun with the calculator and not too hard. But on the next page, we have some interesting ones too, and these are a little bit tougher. Sine theta equals approximately, and all these answers are approximate answers. They're not exact. So they put wavy lines. You know, these are approximate answers. 0.96770915. Call that number, ask for a sand. No, just kidding. All right, so now we got this. I want to find out what theta is. I want to find the angle. Now, here we were trying to find a relationship that had something to do with the side. So we were going directly, we were hitting the side. But here we want to find theta. When we're looking for a theta, we have to use an inverse function. So what I'm going to do is I'm going to take this sine over to the other side, and it becomes inverse sine. Doesn't mean sine 1 over the sine. It's just, this is inverse sine. 0.9770915. Back in the dark ages when I went to school, we called that arc sine. And I still sometimes like to use that, and I don't get confused with this negative exponent. This is the arc sine. Sine on this side, sine, this would give me the angle, 0.9770915. So how do I do that? To do that on my calculator, when I'm looking for theta and I have an arc sine, the arc means hit the second. See, that's why I kind of like the arc better. Let's clear this out. Second and then sine. See how it has the little -1 there? Inverse sine, see? Or you could write inverse sine. And then we're going to actually calculate it out, 0.977. Real easy, huh? 0.915. Parentheses, and then hit equals. And see, that gives me an angle, and this angle is in degrees. 77, I'm not going to carry it all the way out. You know, degrees we usually carry out 1 or 2 places. 712 degrees, you know, that's pretty accurate. So around 77 some degrees. Did I get it right? Let's double check. They got 75. What did I do wrong? It was 967. Put it wrong. Let me try it again. Okay, second sine. Let me look at the book and put in the right number here. 0.967. You can see I was pretty close anyhow. 709, but not exact. 15 parentheses equals. There we go. 75. 0.39. I call it 0.4 degrees. Okay, so I rounded it up. You know. 75.4 degrees. Okay, let's try another one. Here's a terrible one. Again, we want to find the secant. The secant theta is equal to 1.0545829. Pretty big number. So I want to find theta. Bring this over to the other side. That's the inverse, or arc. But I don't have the, I bet you I copied that wrong too. There we go. I don't have the secant. So what I'm going to do is change theta is equal to, I'm not going to put 1 over the cosine. I'm going to put cosine inverse, and then I'm going to put this as 1 over 1.0545829. Now on other calculators, it might be different, but on this calculator, that's how you have to do it. So let's take a look at this thing. Second cosine, and it should appear that way. 1 divided by, and then put this big old number, 1.0545829. Parentheses equals 18.51. So I'm just going to round this off to 18.5 degrees. And there I got my answers. So you can mess around a little bit with this, have a little fun with it. We're not going to worry about example 3. You know, I'm looking at my book in problem number 15. It says 1 over the cotangent. You would write that as the tangent of 23.4 degrees. So, you know, you can do all kinds of things. Look at problem 21. You'd probably want to subtract that first. 1 over the cosecant of 49 would be the, and I have this written wrong in my book. It would be the cosecant goes with the sine. That would be the sine of You could do the sine of 51, sine of 49 degrees, or the cosine of 51 degrees. So, you can mess around with these things, practice them. Get good on that calculator, you'll be using it quite a bit. Okay, the next section I want to cover is solving right triangles, the heart of algebra right here. Solving right triangles. So take a look at section 2.4. Let's look at example 1. I usually stretch my triangle like this, kind of a generic one, right triangle here. This would be side A. This is B. C is always your right angle. The C is always the right angle. The sides opposite them are little c. Side opposite A is little a. Side opposite B is little b. Lowercase b. So that's how I draw my triangle. And normally we draw it this way. In this case, they gave us this triangle and they said A was 34 degrees in 30 minutes. And C was 12.7. And what we have to do, this was inches, put 2 little marks. Okay. And then what they want us to do was find side A. Let's write down what we got to find. Side A. They want us to find side B. And they want us to find angle B. That's what we're trying to find, those three things, given this information. And this is the fun part. So let's go looking for A. If I go to look for A, I notice that the reason I'm going to use I have this angle. So I notice that this is the opposite of that angle. This is the hypotenuse. I like to label this, and this is the adjacent, checking using this angle right here. So I need to find A, I need a relationship that involves the opposite and the hypotenuse. The opposite and the hypotenuse. So what would that relationship be? That would be the sine. The sine of 34 degrees, 30 minutes, I'm going to write it like this, is equal to the opposite, which is A, over the hypotenuse, which is 12.7. So how can I find A? Well, this is basically a proportion. We could technically put this over 1 and cross multiply. 1A equals the product of these two. So A is equal to 12.7 times the sine of 34 degrees, 30 minutes. And I can just enter that into my calculator that way. Let's try it. Clear. 12.7 sine 34, and now let's go to degrees, equals, and 30 minutes, 30, let's go to minutes, slide it over, equals, close the parentheses, equals 7.19. They're carrying out 2 decimal places. You see how easy that was? I didn't even have to put a time sign in there. Now, if you're not using this calculator, it may be different. I can only tell you how to do it on this calculator. But you can see, very equal. And we want to put inches so we don't get confused that we were trying to find degrees. Okay, what about finding B? Let's find B. Okay, B is the adjacent over the hypotenuse. What relationship is that? We know this was sine. What is the adjacent over the hypotenuse? Cosine. So the cosine of 34 degrees, 30 minutes equals the adjacent, which was B, over the hypotenuse, 12.7. So once again, I can just multiply those together. B equals 12.7 cosine 34 degrees, 30 minutes. This is what we call showing our work. Okay, so I know how you get this. So now I can just enter it in my calculator, and let me show you a trick I'm going to use, because I don't want to retype on this. I'm going to go up. I'm going to slide over to sine. Where it says sine, I'm going to tap cosine. And now I got it in terms of cosine, because it was exactly the same equation. And that's why I like this calculator. Then I'm going to hit equal, and I've got my answer. B is 10 point, I don't know what it, probably 47 inches. Let's turn the page and see if we got it right. Well, they rounded it off to 10.5, but yeah, we're more accurate. Now let's find angle B. Angle B is equal to 90 degrees minus angle A. So it's equal to 90 degrees minus 34 degrees, 30 minutes. Okay, you could borrow, but make this 89.60, which wouldn't be hard. I could probably do it in my head, 45.30. But I'm going to use my calculator. 90 degrees. Let's put in the degrees just to make sure. Minus 34 degrees, 30 minutes. To me, this is the long way of doing it, but, it still work. Slide over. Equals 55.5. See, it changed it to a decimal. So we probably didn't want that, because I'll write it down here, 55.5 degrees. But since this was in, minutes, they probably wanted it written that way. So I'm going to change the 90 to 89 degrees, 60 minutes. And then I'm going to subtract 34, 30. See, that'll give me 55, 30. So like I said, sometimes the calculator isn't always the best. I guess we could change that. Maybe there's a way we could change it. I don't think so, because this is on top RP that has something to do with something else. Anyhow, we have it done. So the next thing I want to do is box off these answers so Mr. Mitchell could actually find your answers on your paper. He doesn't have to go playing hide and go seek. Okay? Be proud of the answers. You worked hard on this problem. Be proud of what you've done. All right, let's try one more. The angle of elevation is equal to the angle of depression. I remember that from physics. The angle of elevation, going this way, is equal to the angle of depression, going this way. So let's take a look at one. It says, Pat Porterfield. This is example 3. Or should we try? Let's try example 2. Maybe we jump ahead. Well, we do example 2 afterwards. Pat Porterfield knows that when she's standing 123 feet from the base of a flagpole. And why is she doing this? I don't know. But she's standing 123 feet here. What's her name? Pat Porterfield. And she realizes that the angle of elevation to the top of this pole is 26 degrees. And of course, they had to give this in minutes, 40 minutes. And her eyes are 5.3 feet above the ground. So this is 5.3 feet. So she wants to know, what is the height of the flagpole? Okay, so when we calculate this flagpole, which is from here to here, we have to subtract off this 5.3 feet, because she's adding that to the drawing. She's not really seeing this. She's seeing it from this perspective. So it's going to be taller. So when you get through, Do we subtract it off or do we add it to the flagpole? Let's see. We're going to actually have to add that to the flagpole. Huh? We're going to have to add that back onto the flagpole. Okay, so anyhow, let's look at this drawing right here. Let's call this angle A, this is B, this is C. We're looking for A. And then this right here would be side B. This right here is the opposite. And this right here is the adjacent. So in order to find A, I need a relationship using A and B because I don't have the hypotenuse and I don't want to find it out. So I want to use a relationship. So I'm going to use opposite adjacent. What is that? That's the tangent. The tangent of angle A is equal to the opposite over the adjacent, 123. We'll put B here. So the tangent of 26 degrees, 40 minutes is equal to A over, which is this, 123. So let's calculate it out. Tangent. So let's multiply here, 123 tan. Now, sometimes the number might be up here and the A is down here. Maybe, well, let's get into that in a minute. Let's finish this one. 123 tangent 26 degrees 40 minutes. What does that equal? 123 tan 26 degrees. Back in the old days, we had to look this up in tables. Slide over or convert to decimals and then convert back. Pain equals parentheses. Okay, I think I got it in equals. I got 61.77. They rounded it off to 61.8. There's the height of the flagpole. Let's put feet. And then they added on the extra because it was from her eyes above the ground. So she would be actually looking up here. So we had to add the 5.3 to it. So that'd be 11. I could use my calculator, but I'm not going to. 67.1 feet. There you go. Okay, one last one. I know you're doing pretty good on this. Let's try one. This might be a little trick here. Here we got another triangle. They kind of drew it a little different. It's okay. It's always best to draw the drawing. Whoops, here. I drew it the same, didn't I? All right, let me start that one over again. Okay, it looks like this. Okay, if you can't laugh at yourself, who else can laugh at you? Okay, here's A, B, C. This is side A. This is side C. This is side B. This side is 29.43 centimeters. And this side right here is 53.8, 58. It says A and B. So I want to find us all the sides, all the angles and stuff like this. So we need to find side B, we need to find angle A, and we need to find angle B. And of course, we know angle C is 90 degrees. So we already got that. So they started off by trying to find this angle right here. So they realized that this is opposite and this is hypotenuse. So they're going to use the sine function. The sine of A equals the opposite over the hypotenuse. The sine of A equals opposite would be 29.43 over the hypotenuse, which is 53.58. But we want the inverse function of that. So again, we're going to bring this over. A is the inverse function of this thing. So we could do this all in one step if you want. You could do it in 2 steps, but we're going to do it in 1 step. What the heck? Okay, so we're going to hit second sine, see, because I'm doing inverse, 29.43 divide 53.58. That way we don't have to do 2 different values, equals 33.3. And that's the number of degrees. Let's see if that's what they came up. Well, they came up with 33. Well, they changed it. We don't want to. We want to keep this in decimals. 33.3 degrees is good. If you want to put 33.32, it didn't really say it calculated in degrees a minute. So I would just go, if it doesn't ask you, just do it in degrees. And don't worry about degrees and minutes, Use a decimal. Okay, we want to find, so we got angle A. We want to find angle B. Well, obviously 90 degrees, take away 33.3 would give me B. So that would be 89.00. 3 from 10 is 7. 3 from 8 is 5. 55.7 degrees. Did I get it right? I subtract from. How do you get 56? Oh, this was 90. I want to change it to 89. What am I talking about? Golly. 56.7. Sorry, they're right. Teacher is wrong again. It's worn out this week. Okay, finally, you want to find side B. You can do it a couple of different ways. We could use the we could use the Pythagorean theorem. I think that's what they used. They used the Pythagorean theorem. I'm not going to use the Pythagorean theorem. I'm just going to use the sides we have here. We have the opposite, right? And we have the adjacent. We're trying to find B. Let's use angle A. And let's use a relationship that uses the opposite and the adjacent, which is what? Tangent. The tangent of angle A is the opposite over the adjacent. Tan A equals opposite. Now, this won't be quite as accurate as using the Pythagorean theorem, but it'll be accurate enough. So I wanted to show you how this works, because sometimes you're solving for a variable in the denominator. We can switch these. So this, B is going to equal 29.43 over the tangent of A, which in this case is the tangent of 33.3. And let's see what we get. So we can enter it on our calculator just that way. 20, let's see if we come up with pretty close to the answer, 43. It probably won't be quite as accurate, but we'll see. Tan 33.3 is already in degrees. Don't forget to close it off. Equals. I come up with 44.8. What did they come up with? 44.77. So we're pretty close. You can see we're pretty close centimeters. So they came up with 44.77, 44.8. This is much quicker than using the Pythagorean theorem. When B is on the bottom, notice what I did. I did a switch trick. I switched both of these. Put B on the top, tangent A on the bottom. Pretty fast way of doing that. On a proportion, these are always interchangeable. Same thing this way. All right, so kind of a fast way of doing it. We found Let's write that in and circle it. And there you go. Your teacher can find it. So I hope you enjoyed this video. Use your calculator. Become friends with it. When you become friends with your calculator will become friends with you.